Hello, students. Professor Piggy here. Today we are talking about protecting data, which I tell my students is the corn, the apples, and the grain silo all rolled into one. Data is one of the most valuable resources an organization manages, second only to its people, and that makes it a prime target for the wolf, who is always sniffing around for a weak fence or an unlocked barn door. You have heard the stories of data breaches splashed across the news, and sadly, they are not fairy tales. When data is stolen, cyber criminals can drain bank accounts, commit credit card fraud, and steal identities, causing real harm to real people. For an organization, losing control of data damages trust, reputation, and often the financial bottom line, which is exactly what the wolf hopes for when he slips into a poorly protected network. One of the primary goals of attackers is the theft of data, which we formally call data exfiltration. Data exfiltration is the unauthorized transfer of data outside of an organization. Once the wolf gets inside the network, he often tries to gather proprietary information and sneak it out quietly, although sometimes he simply locks the barn doors with ransomware and demands payment to restore access. Organizations respond to these threats with security policies that define how data should be classified, labeled, and protected. These policies help identify which data is confidential, which is personally identifiable information, and which is proprietary. From there, technical and administrative controls are selected to protect data according to its importance, ensuring the strongest locks are placed on the most valuable stalls. A major technical control used to stop data from walking out the door is data loss prevention, commonly called DLP. Data loss prevention refers to techniques and technologies designed to prevent data exfiltration. DLP systems can block the use of removable media, monitor outgoing communications, and detect unauthorized attempts to transfer sensitive data, even when the wolf is wearing a disguise. In a network-based DLP deployment, all traffic leaving the network is routed through a specialized appliance. Administrators configure the system to look for specific words, phrases, or character strings associated with sensitive information. For example, if a secret project uses a specific code word, the DLP can scan emails, attachments, and file transfers for that keyword and block the transmission when it is detected. When a DLP system detects a violation, it can be configured to take several actions. It might silently block the transmission, notify security personnel, alert the user who attempted to send the data, or do all of these at once. This allows organizations to stop the wolf in his tracks, while also educating well-meaning employees who may have made an honest mistake. Software-based DLP works in a similar way, but is installed directly on individual systems. It monitors activity on that specific device and prevents unauthorized data transfers from succeeding. This is especially useful for laptops and remote systems, where data might otherwise slip out through local actions rather than network traffic alone. Modern DLP systems are quite thorough in their inspections. They can scan the text of emails and the contents of attachments such as documents, spreadsheets, presentations, and databases. While many DLP systems can inspect compressed files or flag suspicious encrypted traffic, highly sophisticated attackers may still evade detection. Defense in depth is key. A common use case for DLP is the protection of personally identifiable information, or PII. Personally identifiable information is data that can be used to identify an individual, such as a social security number. DLP systems can use pattern matching to detect formats like 3 digits, a dash, 2 digits, a dash, and 4 digits, and block any outgoing message that contains such data. Organizations often classify and label their data using terms like confidential, PII, or proprietary. These labels make it easy to configure DLP systems to search for specific keywords or metadata. When the data is clearly marked, it becomes much harder for the wolf to carry off without triggering an alarm. Network-based DLP is not limited to email traffic. It can also inspect other protocols, such as FTP and HTTP. Although sophisticated attackers may encrypt data before sending it out, many DLP systems can detect unusual or unauthorized encrypted outbound traffic and alert administrators that something suspicious is happening.
Another significant risk to data comes from removable media. Removable media refers to storage devices that can be easily connected to a system to copy data. Examples include USB flash drives, external hard drives, SD cards, CDs, DVDs, and even smartphones with storage capabilities. Because removable media can be used to steal data or introduce malware, many organizations restrict or prohibit their use through policy and technical controls. Some environments completely block USB storage devices, while others use USB data blockers. A USB data blocker prevents data from being written to or read from a removable device, stopping both data theft and malware delivery. While DLP and removable media controls are important, the strongest protection for confidentiality is encryption combined with strong access controls. Encryption is the process of converting data into an unreadable format using a cryptographic algorithm in a key. Encrypted data is much more difficult for an attacker to understand, even if it is stolen. Encryption should be applied to data at rest and data in transit. Data at rest includes information stored on hard drives, solid-state drives, and removable media. Data in transit includes information moving across networks, whether wired or wireless, and encryption protects it from eavesdropping by the wolf as it travels. Access controls alone are not enough to protect confidentiality. File system permissions, such as those provided by NTFS, can restrict who is allowed to read or modify files. However, if a device is stolen, an attacker can often bypass these permissions by accessing the storage from another system, which is why encryption is critical. Encryption can be applied at multiple levels depending on organizational needs. Entire disks can be encrypted, individual partitions or volumes can be protected, and even specific files or directories can be encrypted. Rather than encrypting an entire database, it is common to encrypt only specific fields or columns that contain sensitive data. CompTIA calls this record encryption, targeted protection of specific records or fields or columns, also known as column-level or field-level encryption, while broader protection of the whole database is simply database encryption. Record encryption, also known as column-level or field-level encryption, protects individual fields like credit card numbers or security codes without encrypting less sensitive data such as names or customer IDs. This approach reduces processing overhead while still protecting the most critical information. It's a smart way to guard the juiciest apples without wrapping the whole orchard in wire. Passwords stored in databases are often protected using hashing or salted hashing. Hashing is a one-way cryptographic function that converts data into a fixed-length hash value, or digest. Salting adds random data to the input before hashing, making it more resistant to attacks such as rainbow table lookups. Another important concept is protecting data in use. Data in use refers to data that is actively being processed by a system or application. During this time, sensitive information like passwords and encryption keys can be exposed in memory, making it a tempting target for attackers. One advanced method of protecting data in use is the secure enclave. A secure enclave, also known as a trusted execution area, is a hardware-based, isolated area within a system designed to process sensitive data securely. Technologies such as Intel software guard extensions create an environment where data can be processed even if the rest of the system is compromised. By combining strong policies, data loss prevention, removable media controls, encryption, database security, and protections for data in use, organizations build multiple layers of defense. Each layer makes it harder for the wolf to succeed, and together they form a sturdy brick house that keeps valuable data safe. Like and subscribe for more cybersecurity wisdom. Oink!